Welcome back to the Deep Dive, your go-to source for unearthing the most crucial nuggets of knowledge from complex material, transforming you into an instantly well-informed expert, all seasoned with a dash of the unexpected.
Ah, yeah, a dash of the unexpected. I like that.
Today, we're embarking on a mission critical for anyone navigating the brave new world of artificial intelligence. We're taking a truly exhaustive deep dive into Chapter 3, Part C, Data Management Controls from the ISECA AAISM Review Manual.
That's right.
Think of this as your essential expert-guided tour, packed with the insights you need if you're interacting with, building, or even just thinking about deploying AI systems.
And our mission, your learning objective for this deep dive, couldn't be clearer. By the time we're done, you'll possess a crystal clear understanding of why robust data management and stringent security aren't just technical checkboxes to tick off.
No, far from it.
Far from it. They are, in fact, the fundamental pillars that underpin the trustworthiness, the absolute reliability, and ultimately the utility of any AI system you encounter or create. Without them, even the most brilliant algorithms are built on sand.
Exactly. We're approaching this material with the precision and impartial focus it demands, just as if you were right here in a classroom with us as your dedicated instructors guiding you through these critical concepts. So let's roll up our sleeves and dive straight into the intricacies of AI's most foundational element, its data. Hashtag tag tag II. The crucial role of data management controls in AI. Section 3.4 overview. Okay, let's really unpack this right from the start. Why is data management so incredibly critical for artificial intelligence? It feels like such a foundational topic for any technology, but for AI, it seems to take on a whole new dimension of importance, almost like it's AI's greatest Achilles heel if not handled properly.
You've hit on a core truth there. The greatest Achilles heel of AI isn't its complex algorithms or the sheer processing power it demands. It's something far more fundamental and often surprisingly overlooked. It's data.
Right.
Because at its core, data is truly the lifeblood of AI. Without meticulously managed, high-quality data, AI solutions simply cannot function effectively, reliably, or perhaps most importantly, securely. The ISECA manual makes this perfectly clear by stating that data isn't just a simple input that goes into an AI model once and then you're done. That's a common misconception.
Yeah, I think a lot of people think that.
They do. No, it's a dynamic element. It flows through every single stage of an AI system's life cycle.
Every single stage.
Everyone. We're talking about the entire journey, from its initial design, how you even conceive of the data you'll need, through the intensive training phase where the AI learns its patterns and makes sense of the world, into its ongoing operation, where it makes decisions based on real-time data, and even to its eventual decommissioning when the system is retired and its associated data needs to be managed. This continuous flow means data is central to everything the AI does.
That's a powerful point. If data is flowing through every single stage, it inherently means that every point in that data journey, from the moment you acquire it, through all its transformations, to its final deletion, is a potential vulnerability.
Precisely.
It's not enough, then, to just focus on securing the AI model itself almost in isolation. The data it relies on has to be sound, protected, and of unimpeachable quality at all times.
Absolutely.
It's like trying to build a gleaming, sophisticated skyscraper on a shaky, crumbling foundation. It doesn't matter how strong the steel frame is if the ground beneath it isn't stable. A flaw in the data can unravel an entire AI system, much like a single compromised brick can jeopardize a whole building.
That's a perfect analogy. And that pervasive, continuous role of data is precisely why the source mandates that security and risk evaluations aren't just one-off checks or an afterthought that you tack on at the very end of a project.
Right, not just a final checkbox.
Exactly. They must be continuous and fully integrated into each stage of the AI lifecycle. You need to assess risks at data acquisition, during data preparation and cleaning, when the model is being trained on sensitive information, when it's deployed and processing live data, and even when data is being archived or destroyed.
Wow, okay.
If you think of building that secure structure, it's about ensuring the quality and integrity of every single brick, every connection point, every beam, not just admiring the overall architectural blueprint. It requires constant vigilance and embedded controls from start to finish.
So why should you, our listener, care about this beyond just understanding the technicalities? Because AI is not just a theoretical concept anymore. It's rapidly becoming woven into the very fabric of critical business processes, national infrastructure, and increasingly our daily lives.
It really is everywhere now.
It is. If the data that fuels these AI systems is flawed, biased, or compromised in any way, whether through human error, technical glitch, or malicious attack, the AI's decisions can lead to significant operational disruptions for businesses.
Hmm.
We're talking about potential privacy breaches that can affect millions of individuals and, in some critical applications, even real-world physical safety concerns. Imagine an autonomous vehicle making a flawed decision due to corrupted sensor data, or an AI in healthcare providing an incorrect diagnosis because of biased training data.
Scary thought.
It really is. It's about protecting more than just data. It's about protecting the outcomes that these AI systems influence and ultimately protecting people. The stakes are incredibly high.
Hmm.
So, given this pervasive role of data, what does this all mean when we talk about practical application? How do we even begin to control something as dynamic and ever-present as data in an AI context? It sounds like we need some serious ground rules, a kind of constitution for data right from the outset.
You've hit on the exact concept. We need robust data governance.
Data governance. Okay.
Data governance is the overarching framework that dictates precisely how an organization manages all its data. The goal is to ensure that this data management aligns perfectly with the organization's overall AI program strategy and, critically, its security objectives.
Got it.
It's about establishing clear principles, comprehensive policies, and robust processes for every aspect of data handling, from cradle to grave. It brings structure and accountability to the often chaotic potential of vast data sets.
Makes sense.
The ISACA manual, our source, is very clear about the importance of considering 5 critical questions, which they lay out in Figure 3.13, especially when acquiring data for AI solutions. These aren't just rhetorical questions, they're essential, actionable checkpoints for data acquisition and for maintaining ongoing data integrity. Ignoring any one of them can have cascading negative effects.
Okay, let's break those down because they really get to the heart of what makes data governance so crucial, setting the stage for everything that follows. The first question, according to the source, is what is the origin of the data and where is the recipient organization in the life cycle of this data?
Yeah, this one's fundamental. This question really underscores the concepts of data lineage and provenance.
Lineage and provenance, okay.
Data lineage asks, where did this data come from? Who created it? How has it been transformed or aggregated along its path? Provenance speaks to its trustworthiness. Is its source reliable? Is it a reputable provider?
Right, can you trust it?
Exactly. Understanding the entire journey of the data helps an organization assess potential biases that might be inadvertently embedded. Perhaps the data was collected from a non-representative sample or quality issues that could have crept in along the way, like missing values or inconsistencies.
Mm-hmm.
Critically, it also helps identify compliance risks right from the very beginning. For instance, data collected years ago for a specific purpose might have different consent parameters or quality than newly generated data, making it unsuitable for AI training without careful reevaluation.
Ah, okay.
This also informs how your organization integrates it into its own existing data ecosystem, ensuring compatibility and secure transfer. Without understanding its origin, you're bringing in an unknown quantity.
Moving on to the second question, which highlights accountability, especially in complex environments. If an organization provides data to an AI solution for processing, who is responsible for the processing?
This is a vital point, particularly in today's increasingly complex, multi-party AI ecosystems. Think about scenarios involving cloud providers, third-party data services, or even collaborative partnerships where data is shared for AI development.
Yeah, it's rarely just one company involved anymore.
That's right. Even if your organization is primarily the recipient of data for an AI solution, you need a crystal clear understanding of who is responsible for its processing. This ensures unambiguous lines of responsibility and, crucially, liability.
Liability, that's key.
Absolutely. Without this clarity, when a security incident or a compliance breach occurs, you're left with a confusing who's on first scenario, which can have significant legal and reputational repercussions. Clear responsibility is vital for both security and legal compliance, especially when dealing with personal or sensitive information. It's about defining the boundaries of duty.
And the third question delves into internal accountability, something that's often overlooked when data becomes too siloed. Who are the data stewards and owners of the data, and what are their responsibilities?
Data stewards and data owners are specific individuals or teams within an organization who are explicitly accountable for particular data assets. They are the guardians of that data.
Guardians, I like that.
Their responsibilities are comprehensive, ensuring data quality, safeguarding privacy, and upholding the security of that data throughout its life cycle. This is particularly crucial for proprietary or highly confidential information.
Makes sense.
By clearly assigning these roles, organizations prevent data from becoming orphans. Data that exists within the system but has no one accountable for its upkeep, quality, or security. It ensures ongoing active oversight, which is paramount for AI that constantly consumes and generates data. This proactive ownership is key to maintaining a healthy data ecosystem.
Now, the fourth question really fits on a timely and critical issue, especially in our privacy-conscious world. Are the necessary consents in place to use the data in the intended manner? Even if consent to process data is confirmed, is the type of consent provided broad enough to allow the processing activity?
This question is absolutely paramount for privacy, and it sits at the very heart of building ethical AI systems. Consent must always be specific and informed. This is a critical distinction.
Specific and informed, not just a checkbox.
Definitely not just a checkbox. Data collected for one purpose, say, to improve a customer service chatbot by analyzing conversation logs, might not have the necessary consent for another, completely different purpose, such as training a facial recognition AI system that analyzes customer emotions from video feeds.
Ah, okay. So you can't just reuse it for anything.
No, you absolutely cannot. Repurposing data without explicit, appropriate, and broad enough consent is a significant legal and ethical risk. We've seen numerous examples globally where companies have faced enormous fines and suffered severe reputational damage precisely because they failed to manage data consent properly. It's not just about having a consent. It's about having the right type of consent for each specific use case and ensuring that use case was clearly communicated to the data subject when consent was obtained. This is where many organizations stumble, leading to serious legal consequences and public backlash.
And finally, the fifth question, which feels like it ties everything together with a bow, ensuring ongoing vigilance. Is the data current, accurate, and up to date? The data of concern needs to be consistent with the organization's data management policies and the laws of each data subject's jurisdiction.
This is where data quality directly intertwines with AI performance and fairness. If the data fed into an AI model is outdated, inaccurate, or incomplete, the AI's outputs will be unreliable, potentially biased, and ultimately ineffective.
Garbage in, garbage out, right?
Exactly. An AI model is only as good as the data it's trained on. Imagine an AI designed to predict market trends based on 5-year-old financial data. Its predictions would be useless.
Yeah, totally useless.
Beyond just quality, this question emphasizes the critical need for continuous compliance with evolving data privacy laws across different jurisdictions, like GDPR in Europe or CCPA in California.
Oh, right, the geographic differences.
Exactly. Data collected in one region might be subject to different rules regarding its use, retention, or destruction compared to data collected elsewhere. Organizations must ensure their data management policies are dynamic enough to keep pace with these legal complexities, constantly auditing and updating their data to ensure both relevance and compliance.
So here's where it gets really interesting for me, and I suspect for you too. These aren't just technical questions for engineers tucked away in a data center.
Not at all.
They are fundamental business and ethical questions that ripple through the entire organization, from legal teams to marketing to product development and even executive leadership. They demand cross-functional collaboration.
Absolutely. Think of these 5 questions as the pre-flight checklist for any data destined for AI.
Ah, the pre-flight checklist. Good one.
Just as a pilot would never dream of taking off without meticulously checking every system, every gauge, every single detail on their pre-flight checklist, an organization should not, under any circumstances, feed data to an AI system without meticulously verifying its origins, understanding who is responsible for its processing, confirming all necessary consents are in place and are broad enough, identifying clear data stewards and owners, and ensuring its currency and compliance.
You wouldn't skip steps on a plane.
You certainly wouldn't. Skipping any of these steps is akin to flying blind into a storm. It's about ensuring the raw material is pure and permissible before you even begin to build. The quality of your AI's decisions will directly reflect the quality of this initial data governance. #33 Data Organization and Preparation for AI, Section 3.4.4.
Okay, so the governance framework is established. We know the rules of the road for data, and we've got our pre-flight checklist in hand. But getting raw, messy data from various sources ready for an AI model, that sounds like a massive, highly technical undertaking, almost like alchemy. How do we actually do that? What are the practical steps in organizing and preparing this data to make it AI ready?
You're right, it is a significant undertaking, and it's precisely where the rubber meets the road. Data organization and preparation are critical stages where raw, often unrefined data is transformed into a usable, secure, and high-quality format that's specifically optimized for AI model training and ongoing operation.
Right, making it usable.
Exactly. This phase directly impacts the AI's performance, its integrity, and ultimately its trustworthiness. If you put garbage in, you get garbage out, like you said. Our source points to several key aspects here, and they're all about meticulous detail and control, ensuring that the data pipeline is as robust as the AI itself.
Let's start with what the source calls data flow mapping. What exactly does that entail, and why is it so important for AI given how much data moves around in a typical enterprise?
Data flow mapping is essentially creating a visual representation, literally a map of how data moves within an enterprise.
Okay, like a flow chart for data.
Kind of, yeah. It's about understanding the entire journey of a piece of data. What specific data exists? Where did it originate from a customer database, a sensor, a third-party feed? Where does it go after it's acquired? What kinds of transformations, cleaning, or aggregation does it undergo along its path? Is it anonymized, enriched, or combined with other data sets? Crucially, who accesses it at each stage and under what permissions? And finally, where is it stored at different points in its lifecycle, including temporary caches or archival systems?
Wow, that's a lot to track.
It is. The source highlights data flow mapping as absolutely essential for implementing effective security controls. By meticulously understanding every single step in that flow, organizations can pinpoint potential points of compromise, identify instances of unauthorized access, or detect areas where data leakage might occur.
I see.
It's also vital for efficiently managing data for both your training data sets, the data the AI learns from, and your testing data sets, which are used to evaluate its performance. Without this map, you're essentially trying to secure something invisible, like guarding a complex maze you've never seen before.
That makes perfect sense. If you don't know where it's going and who's touching it along the way, how can you possibly protect it? Next up is data integrity monitoring. I imagine this is about making sure the data doesn't get corrupted or changed, especially given the scale of AI data.
Precisely. AI models are incredibly sensitive to data quality. If the data fed into them is corrupted, maliciously altered, or simply incomplete, the AI's outputs will be unreliable, leading to poor performance or even dangerous decisions.
Yeah, you wouldn't want that.
Definitely not. Consider an AI that's supposed to detect fraudulent financial transactions. If its training data has subtle errors or is tampered with, it could either flag legitimate transactions as fraudulent or, worse, miss actual fraud.
Oh, wow.
The source specifically calls for the use of automated tools to monitor data integrity. This isn't something you can realistically do manually for large, constantly updating data sets.
So automated tools are key here.
Absolutely key. These automated tools perform real-time checks for inconsistencies, unauthorized modifications, and anomalies that could potentially indicate a security breach, or even worse, a data poisoning attempt.
Job poisoning. That sounds bad.
It is. It's where malicious data is intentionally introduced to manipulate the AI's learning process. Maintaining integrity is about ensuring the AI is learning from truth, not fiction, because even a tiny bit of poison can corrupt the whole well.
And it sounds like this isn't just about the initial setup. Data security across the lifespan implies continuous attention, far beyond just putting it in a secure database.
That's right. Security is never a set-it-and-forget-it operation, especially with AI data that is constantly in motion and being transformed. The role of security professionals extends across the entire data lifecycle within the AI context.
The entire life cycle.
Yes. This means from the moment the data is initially acquired, through its rigorous preparation, cleaning, transformation, labeling, its active processing by AI models, its storage, and right up to its secure deletion.
Okay.
Specifics here include ensuring that data is encrypted both at rest, when it's sitting idly in a database or storage, and in transit, as it moves across networks, perhaps between different cloud services or internal systems.
Encryption everywhere.
Pretty much. Access must be strictly controlled through robust authentication and authorization mechanisms, ensuring only those with a legitimate need can interact with it. And crucially, any sensitive data must be appropriately masked, anonymized, or pseudonymized to protect privacy while still allowing the AI to glean insights. This continuous vigilance is the bedrock of secure AI.
This all sounds like a huge balancing act between enabling AI to function and keeping its data safe. And you mentioned proactive risk management earlier. How does that fit into this complex process of data organization and preparation?
It's tightly integrated, not a separate silo. All decisions related to data organization, preparation, and security must be a collaborative effort. involving not just technical teams, but also data governance and data management teams.
So teamwork makes the dream work.
Huh, something like that. It ensures that these decisions align with broader business objectives, comply with legal requirements, and fit within the organization's defined risk appetite. For instance, deciding whether to use a certain external data set might involve a legal review for compliance, a data science review for quality, and a security review for risk.
Right, multiple perspectives.
The source makes a critical point here. Risk management processes should be followed each time data is imported from external sources. This points to a continuous, proactive stance. It's not about reacting to incidents, but about continually identifying and mitigating potential data-related risks before they become problems, especially with new, potentially unknown data sources that could introduce unforeseen vulnerabilities or biases.
And finally, data preservation discussions. This implies that even how long you keep data is a security consideration, which might seem counterintuitive to some.
Absolutely. Discussions around data preservation, in other words, how long to keep specific data sets, must be closely linked to both privacy and security requirements.
Okay.
While some data may need to be retained for regulatory compliance, audit trails, or even future AI model retraining or auditing, holding on to data longer than necessary dramatically increases privacy risks. Every extra day you keep sensitive data is another day it's vulnerable to a breach.
The longer you keep it, the bigger the risk.
Precisely. It also expands the potential attack surface for malicious actors, giving them more time and more data to target. It's a delicate balance between needing data for future insights and the principle of data minimization, which states you should only collect and retain data for as long as its purpose requires. Unnecessary retention is a ticking time bomb.
Imagine you're preparing ingredients for a highly complex scientific experiment in a state-of-the-art lab. You need to know exactly what each ingredient is, where it came from, how it was handled through every step, and that it hasn't been contaminated by anything along the way.
That's a great analogy.
The slightest impurity, a tiny deviation in preparation, could ruin the entire experiment, leading to completely unreliable results, or worse, dangerous outcomes. That's essentially what this meticulous data organization and preparation is for AI, ensuring the absolute purity and integrity of its core components, because if the data is compromised at this stage, the AI's output is compromised before it even begins to learn.
Well said. It highlights just how critical this preparation phase really is.
Okay, so we've got the data meticulously governed, organized, and prepared. It's pristine, verified, and ready for action. Now, how do we actually use all this information and store it securely for the AI to do its work? This is where the AI really starts to think and generate its value, right? The moment the fuel hits the engine.
Indeed. Data utilization involves the actual feeding of this meticulously prepared data into AI models, allowing them to learn, analyze, and generate insights. Data storage, on the other hand, addresses the vast repositories where this information resides, often persistently.
Right.
Both of these phases introduce unique challenges, especially given the sheer scale and dynamic nature of AI data today. We're moving from preparation to active consumption.
And when we talk about scale, AI, especially with the rise of modern models like large language models or diffusion models, seems to operate on truly unprecedented levels. This isn't just about big data sets anymore.
That's a crucial point. Modern AI, particularly advanced models like LLMs or other forms of generative AI, operates on scales that were unimaginable even a few years ago.
Mind-boggling scales.
Truly. This means organizations are dealing with enormous volumes of data petabytes, even exabytes, often at incredibly high velocities, data streaming in real time from countless sources. And it encompasses a wide variety of formats and sources. We're talking text, images, audio, video, sensor data, and more, all needing to be processed harmoniously.
The 3 V's on steroids.
Exactly. This sheer scale, what we often call the big data problem on steroids, significantly amplifies the potential for security issues if not managed with extreme care. The more data you have, the more opportunities for something to go wrong, for vulnerability to be exploited. If your controls aren't robust and scalable themselves, it's like trying to secure a single drop of water versus trying to secure an entire ocean.
And it's not just the input data that needs managing, is it? The AI itself can generate entirely new information as an output. How does that fit into the picture of data utilization and storage?
That's a critical and often overlooked aspect highlighted by the source. AI systems themselves can generate new data.
Right, the outputs.
Think about the output from an LLM answering a query, a synthesized image created by a generative model, or a predictive analytical report generated by a business intelligence AI. This newly generated data isn't just a byproduct. It becomes a new part of the organization's data ecosystem, potentially feeding other systems or becoming new training data.
Oh, interesting. So it feeds back in.
It can, yeah. And here's the kicker. It must be subjected to the exact same rigorous security, quality, and governance protocols as the input data.
The exact same. Why?
Because this generated data need to be validated to prevent issues like hallucinations, where the AI invents information that sounds plausible but is factually incorrect or biased outputs from perpetuating misinformation.
Ah, the hallucination problem. We hear a lot about that.
We do. If your AI is generating flawed or biased information, and you treat that as truth without governance, you've amplified the problem exponentially, potentially causing widespread damage.
So we're talking about strict gatekeeping here, not just at the input, but also on the output side. Only the right data in the right way throughout the entire process.
Precisely. It's paramount to enforce that only data flows that are explicitly permitted by your organization's policies and data governance framework are allowed to feed AI solutions. This acts as a critical control point.
Like a bouncer for data.
Yeah, very strict bouncer. It prevents unauthorized or inappropriate data from entering and therefore from influencing the AI system's learning or decision-making. This could mean sophisticated firewalls and access rules that block data from unapproved sources, or ensuring sensitive data is properly de-identified or anonymized before it ever reaches the AI for processing. It's about maintaining a clean, controlled pipeline from the source data to the model and then to the generated output.
And when all this data is being used and generated, where does it all live? How is it stored securely at such a massive scale?
Secure storage mechanisms are non-negotiable for AI data. We need to consider both data at rest, when it's static, like sitting in a database, a data lake, or an archive, and data in transit, as it moves across networks, perhaps between different cloud services, internal systems, or even to edge devices.
At rest and in transit. Got it.
This means deploying robust encryption, not just as a recommendation, but as a mandatory requirement for sensitive data. Strong access controls are also vital, ensuring only authorized personnel and AI components can access specific datasets. Data segregation techniques, such as isolating highly sensitive training data from less critical operational logs, also play a key role in protecting the AI's core assets.
Segregation helps limit the blast radius, maybe.
Exactly. The immense volume and variety of AI data make these security measures even more challenging and critical to implement effectively. A single lapse here could expose vast amounts of sensitive information.
So it's not just about the technical infrastructure and tools, it's about the rules governing the use of those tools and the data itself.
Exactly. Underscoring all of this is the absolute necessity for clearly defined policies and procedures. These policies must govern data quality, privacy, and security throughout the entire data utilization and storage phases. They act as the operational manual, guiding how data is accessed, how it's processed, and how it's secured during its active use by AI models.
The playbook.
Right. Without these robust policies, even the most advanced technical controls can be undermined by human error, inconsistent practices, or a lack of understanding about acceptable data use. Policies translate the governance framework into actionable steps for engineers and data scientists.
Think of an AI system as a powerful, specialized engine, perhaps like the latest jet engine on an aircraft. The data is its fuel.
Good one.
You wouldn't just pour any random liquid into your car's engine, let alone a jet engine. You need the right type of fuel. It needs to be clean, filtered, and it needs to be delivered efficiently and safely without contaminants.
Absolutely not.
Similarly, AI needs high-quality, securely stored data, and the methods of feeding that data into the AI must be meticulously controlled to ensure optimal, safe, and reliable operation. Any impurity in the fuel, any breach in the delivery system, and your powerful engine could falter, leading to inaccurate outputs or even crash entirely, causing significant financial and reputational damage.
That's a great analogy. This area is also constantly evolving. The sheer challenge of securing data at such immense scales, especially with new modalities like synthetic data, data generated by AI that mimics real-world data, and other forms of AI-generated content, will only continue to grow.
Synthetic data, that's a whole other can of worms.
It really is. Organizations aren't just dealing with historical data. They're creating new, complex data assets at an unprecedented pace. This means anticipating future data types, and their unique security requirements will be a continuous, dynamic challenge for AI data management teams, requiring constant adaptation and innovation. It's not a static problem.
Data isn't immortal, even for AI systems that seem to have insatiable appetites for information. Eventually, an AI system no longer needs certain data, or perhaps legal obligations dictate that it must be removed. What happens then? How do we manage the data's end of life gracefully and, more importantly, securely, ensuring it truly disappears?
This stage, data retention and destruction, is absolutely critical for compliance, for privacy, and for overall risk management. Data should never be kept indefinitely.
Never indefinitely.
No, it must be securely and irrevocably disposed of when it's no longer needed for its intended purpose or when legally required. Holding on to data for longer than necessary is not only a privacy risk, increasing the chance of unauthorized access or misuse, but also an increased security liability. Every extra byte of data you store is a potential target for attackers, a potential point of failure.
So, establishing clear time limits for data seems like the first crucial step in this process.
Precisely. Organizations must define clear and comprehensive data retention schedules for all data utilized by AI solutions.
For all data?
Yes. These schedules are typically driven by various factors. Legal mandates, such as GDPR's data minimization principles, which explicitly state that data should only be kept for as long as necessary for the purposes for which it was processed. They're also influenced by industry-specific regulatory requirements or even internal business needs, like maintaining audit trails or historical records for a certain period.
Right. Balancing act.
It is. The overarching principle is to avoid holding on to data for one day longer than is absolutely necessary. It dramatically reduces the organizational data footprint and thus the risk associated with data storage. This isn't just a suggestion, it's a legal and security imperative.
And when it's time for that data to go, destruction sounds very absolute. What does that truly mean in the context of AI data, given its complex nature? Is it more than just hitting the delete key?
Oh, it's far more than just hitting the delete key or moving files to the recycle bin.
I figured.
Destruction requires robust, verified processes to ensure that data is permanently and irrecoverably removed, preventing any unauthorized recovery. This includes data stored across various systems active databases, backups, archives, and even temporary processing environments where data might have been cached or duplicated during AI training or inference.
Everywhere it might have touched.
Yep. Exactly. For highly sensitive data, this can involve physical destruction of storage media, shredding hard drives, degaussing tapes, or cryptographic erasure, where the encryption keys protecting the data are permanently destroyed, rendering the underlying data completely unreadable, even if the bits physically remain. The goal is zero possibility of retrieval, not just hiding it.
Who makes these critical decisions about what gets destroyed and when? It sounds like it needs incredibly careful oversight, given the potential for data loss or unintended consequences.
Absolutely. Decisions regarding data destruction must involve strong, multifaceted oversight from both data governance and data management teams, often in consultation with legal and compliance departments.
Get the lawyers involved.
Always a good idea here. This ensures that deletions are fully compliant with established policies, legally sound, and that no critical information, either for ongoing business operations or for regulatory compliance, is accidentally lost. It's a risk-based decision. It also involves assessing the potential risks and impacts of data loss. For example, deleting certain training data might inadvertently degrade an AI model's performance, introduce new biases into its decision-making, or even make it impossible to audit past AI decisions. So the decision requires careful consideration of these complex downstream effects on the AI system itself.
This is where it gets particularly nuanced and, frankly, quite fascinating for AI. Our source mentions special AI-specific considerations when it comes to destruction. Can you elaborate on these, especially the profound challenge of data that's already baked into a model?
This is truly one of the fundamental ongoing challenges in the AI era. When data has been used to train an AI model, individual data points are not simply stored in a database in a way that can be easily isolated and removed.
Right, it's not like a spreadsheet row.
Exactly. Instead, their influence is baked into the learned parameters, the complex weights, and the biases of a massive neural network or sophisticated algorithm. So the critical question becomes, how do you truly delete an individual's data if it has already influenced the collective learned knowledge and outputs of a complex model?
Wow, yeah. How do you do that?
Well, that's the problem. This presents a profound ongoing challenge for the right to be forgotten, a key privacy principle in many jurisdictions. If you ask a company to delete your data, and that data has contributed to an AI system that still makes decisions impacting you or impacting society more broadly, has your data truly been forgotten in a meaningful sense? It's not a simple undo button.
That's a deep question, and it has significant real-world implications. And I imagine that even if you could hypothetically unbake data, deleting certain data sets can also impact the AI model's performance in unexpected ways, potentially for the worse.
Yes, that's exactly right. Companies need to meticulously consider the impact of data destruction on the AI model itself. Will deleting certain data sets degrade the model's overall performance? Could it introduce new biases or exacerbate existing ones because the AI now has an incomplete picture of the data it originally learned from?
Hmm.
This requires careful assessment and often retraining or fine-tuning of models, which is a highly resource-intensive and time-consuming process.
Expensive too, I bet.
Very. The emphasis for organizations, therefore, is on proactive planning, integrating data destruction protocols throughout the entire AI lifecycle, right from the initial design phase, acknowledging that traditional data deletion methods may not be sufficient or appropriate for complex AI systems. It's about building forgetting mechanisms and data minimization principles into the AI from the ground up, not just as an afterthought. This means considering how your data retention policies will impact model training and retraining strategies long before the data ever enters the system.
This directly impacts your personal rights, particularly that right to be forgotten we just discussed. When you ask a company to delete your data, it's not enough for them to simply remove it from a list or a database entry.
No, it's more complicated.
If that data helps shape an AI system that continues to make decisions impacting you or impacting society more broadly, has your data truly been forgotten? This raises a profound question about digital permanence and an AI's memory, forcing us to rethink traditional data privacy frameworks in the age of intelligent systems that learn and adapt. It's a fundamental tension that society is still grappling with.
It absolutely is.
We've talked extensively about managing data, governing it, and its life cycle, from acquisition to its eventual end of life. But how do we ensure it's truly secure at every point? Let's get into the nitty-gritty of data security specific to AI, going beyond just general cybersecurity practices, because AI introduces new layers of complexity.
Absolutely. Data security in AI focuses on protecting the confidentiality, integrity, and availability, the core tenets of information security of all data used by AI systems.
The CIA triad.
Exactly. This applies whether the data is at rest, in transit, or actively being processed by the AI. The underlying principle is simple, yet profound. Compromised data invariably leads to compromised AI outcomes. If the foundation is rotten, the house will fall.
Makes sense.
The source identifies several key areas here, each with its own unique security considerations and potential vulnerabilities.
Let's start with beta encoding from section 3.5.1. What exactly is that, and where does security, which might seem like a later concern, come into play right at this fundamental step?
Data encoding is a fundamental process where raw, human-readable data, whether it's text, images, audio, or video, must be converted into numerical representations, such as vectors or tensors, for AI models to actually process and understand it.
Turning words and pictures into numbers for the AI.
Precisely. AI models don't see an image or read text in the human sense. They operate purely on mathematical data. This transformation is foundational. The security angle here is critical and often overlooked. This encoding process itself is a potential point of vulnerability. If the encoding algorithm is flawed, insecure, or if the process can be manipulated by an attacker, perhaps through a subtle adversarial attack, it could lead to data corruption, misrepresentation, or even subtle data leakage.
Subtle leakage, meaning information can sneak out.
Potentially. Imagine encoding a highly sensitive legal document for an AI to summarize. If the encoding isn't secure, even if the numerical output isn't directly readable, parts of the original sensitive text might still be inferable or reconstructible from those numerical representations, completely compromising confidentiality. Security controls must be meticulously applied during this transformation to ensure both the integrity and the confidentiality of the encoded data, right from the very first bit.
That's a fascinating and rather insidious vulnerability since it's so early in the process. Next, data access in section 3.5.2. This seems like a broad topic, but I'm sure it has AI-specific nuances given the distributed nature of many AI operations.
It absolutely does. A significant challenge in AI is that these systems often consolidate data from numerous, highly disparate sources. We're talking traditional databases, vast data lakes, external feeds from partners, and even real-time streaming data from IoT devices.
Data coming from everywhere.
Exactly. This creates a complex and sprawling access landscape. To control this, robust access control mechanisms are absolutely essential. This includes developing a centralized AI access control policy, a single overarching set of rules that dictates who and what, including the AI models themselves or microservices, can access AI-related data.
One policy to rule them all.
Sort of, yeah. Role-based access controls, or RBAC, are key here. Limiting access based on the principle of least privilege, ensuring human users and AI models only have the minimum necessary permissions to perform their specific functions.
Least privilege, only what you need.
Right. An AI model designed for image recognition, for instance, should have absolutely no access to sensitive financial records. For human access, multi-factor authentication, or MFA, adds an essential layer of security. And critically, access privileges must be regularly reviewed and revoked when roles change or are no longer needed, preventing stale permissions from becoming security holes.
Clean up old access.
Yes. Unauthorized access to training data, or AI model outputs, can lead to catastrophic data breaches, malicious model manipulation, or the exposure of sensitive proprietary insights derived by the AI. It's an ongoing battle against privilege creep.
The next point is data confidentiality secrecy from Section 3.5.3. This sounds like a core cybersecurity principle, but what's the specific AI twist or added challenge here?
It is a core principle, protecting sensitive information from unauthorized disclosure. But here's the AI-specific dilemma that creates a constant tension. AI models, especially large, sophisticated ones, often require massive, diverse datasets for optimal training and performance.
They're data hungry.
It's extremely. Yeah. And for computational efficiency reasons, these datasets are frequently unencrypted or are decrypted in memory during the training or inference process. This creates a significant tension. How do you achieve high AI performance while maintaining high data confidentiality? It's a real trade-off that organizations grapple with every day.
Performance versus privacy.
That's the crux of it. To address this, emerging techniques are being explored and developed, such as homomorphic encryption, which allows computation on encrypted data without decrypting it, or confidential computing, where data remains encrypted even in memory during processing within a secure enclave.
Fancy stuff. Sounds complicated.
It is, but potentially very powerful.
Yeah.
The principle of data minimization also applies heavily here. Only collect and retain the absolute minimum amount of sensitive data required to achieve the AI's purpose, thereby reducing the attack surface. Failure to maintain data confidentiality is flagged as a critical risk by our source, capable of leading to severe harm for both individuals whose data is exposed and the organization facing legal penalties and reputational damage.
And finally, data backup in Section 3.5.4. This feels like a universal cybersecurity best practice. Is there anything uniquely important or challenging about backing up data for AI systems?
While it's a standard cybersecurity practice, its importance is significantly amplified for AI. Regular and secure backups of all data used by AI solutions, training data, validation data, operational data, and even the model parameters themselves are absolutely vital for business continuity and disaster recovery.
Back up everything related to the AI.
Everything. The unique aspect for AI is the sheer cost and resource intensity of training and retraining models. Losing a massive, meticulously curated training dataset or a critical operational dataset that a production model relies on can completely halt AI development, disrupt production models, and incur significant financial and operational costs, potentially setting back projects by months or even years.
Ouch, that sounds expensive.
Very expensive. Imagine a company whose AI-driven recommendation engine goes down because its training data was corrupted and no backups exist. The revenue loss would be immense. Reliable backups ensure quick recovery from data loss or corruption events, minimizing downtime and protecting the massive investments made in AI capabilities. It's about protecting the intellectual property embodied in that data as much as the data itself.
So what does this all mean for you, the listener? It means that behind every AI interaction you have, every product recommendation you get, or every question you ask a chatbot, there's a complex, multi-layered web of technical safeguards and rigorous processes, all designed to ensure that the data being used is pristine, private, and protected. It's the invisible scaffolding that allows AI to function reliably.
That's precisely it. When you interact with an AI, whether it's getting a product recommendation, a medical diagnosis, or even just asking for directions, you're implicitly trusting that the data it learned from was secure, that your own information remains confidential, and that the system itself hasn't been compromised or maliciously manipulated.
It's built on trust.
Absolutely. These security measures, from how data is encoded and accessed to how it's kept confidential and backed up, are the invisible foundation of that trust. They are crucial for ensuring the AI is not just smart and capable, but also safe, responsible, and ultimately a force for good. Hashtag outro.
As we bring this deep dive to a close, it's abundantly clear that understanding Chapter 3, Part C data management controls from the ISACA AIE AAISM Review Manual has been a foundational, indeed indispensable journey. We've explored why data is not merely an input, it's the core asset, the very lifeblood that flows through and sustains every single stage of the AI lifecycle.
The lifeblood.
This demands meticulous, proactive attention to its governance, its organization, its utilization, its retention, and of course, its robust security.
What's truly fascinating here, and what I hope you take away, is how deeply intertwined the quality and security of data are, with the very essence of AI's trustworthiness and its ability to deliver beneficial, ethical outcomes.
Yeah, they're inseparable.
Totally. It's not simply about preventing breaches or avoiding legal penalties. It's fundamentally about enabling AI to be a force for good, built on an unshakable foundation of integrity.
And as AI continues to learn and evolve, consuming ever-increasing amounts of information from every corner of our digital lives, consider this. How will organizations truly balance the insatiable data appetite of advanced AI, which thrives on vast datasets, with the fundamental human right to data privacy and the ultimate desire for our data to be truly forgotten when its purpose is served?
That's the million-dollar question, isn't it?
It really is. It's a question that will shape the future of AI for all of us, demanding ongoing innovation, not just in algorithms, but in our very approach to data.
A profound thought indeed.
Thank you for joining us on this deep dive. Stay curious, stay informed, and keep engaging with the complex, fascinating world of artificial intelligence. We'll be back soon with another deep dive into the insights that matter.